In this topic, we're going to look at the effect of enzyme and substrate concentration on enzyme activity. So by the end of this topic, you'll be able to discuss the different factors that affect the rate of enzyme activity, and these include substrate concentration and enzyme concentration. Now you remember in the last lesson we discussed pH and temperature. Substrate and enzyme concentration also affect the rate of enzyme catalyzed reactions. So the enzyme reaction is always most rapid at first, as you can see by that steep curve, because the enzyme and substrate molecules can collide freely. If you have a look at substrate concentration, if the concentration of an enzyme is fixed, so you've got limited number of enzymes, and the substrate is slowly added, so you're slowly increasing the substrate concentration, the rate of reaction increases in proportion to the amount of substrate that is added. So here you can see at low substrate concentration, the rate of reaction will be quite low. Then at high substrate concentration, the rate of reaction will be quite high. So as you increase the substrate concentration, so the rate increases until all the enzyme molecules are occupied. And this is when the graph starts to plateau. So let's have a look at what happens when you've got low substrate concentration. At low substrate concentration, there are too few molecules to occupy all the available active sites. So in this case, you've got 4 enzyme molecules and 2 substrate molecules, which are represented by the yellow stars. So the rate of reaction is going to be where that arrow is. It's only going to be half the maximum possible for the number of enzyme molecules available. So your rate of reaction is going to be where that red line is, and it hasn't reached its maximum rate yet. So how do you increase the rate? Well, you increase the substrate concentration. So when you've got twice as many substrate molecules available, so in this case you've got 4 substrate molecules available, all the active sites on those enzymes are going to be occupied at the same time. So the rate of reaction has doubled to its maximum, because all the active sites are filled and you've got enzyme substrate complexes being formed. And this is what we call the Vmax. So this is the maximum rate of reaction. So at Vmax, all the active sites of the enzyme are fully occupied all the time, and you've got enzyme substrate complexes, and then the products are being formed. So this is happening at the maximum rate. So if you add excess substrate concentration, is this going to affect the rate? No. So the addition of further substrate molecules has no effect because all the active sites are already occupied at one time. So there's going to be no increase in the rate of the reaction. It's going to be where that red line is and where the arrow is pointing. So it's kind of reached a plateau. So even if you add more and more substrate concentration, the rate's not going to increase. Now what happens if you change the enzyme concentration? So once the active site on an enzyme has acted on its substrate, it's free to repeat the procedure on another substrate molecule, as represented by this picture. You've got the enzyme and the substrate, the blue and the yellow. Then the enzyme has now got a free active site and the products have left it. This means that the enzyme is not used up in the reaction and it can work efficiently at low concentrations of enzyme. So in some cases, you can have a single enzyme acting on millions of substrate molecules in 1 minute. So you can see this enzyme is now free to bind to another substrate. So let's have a look at this graph. You've got the rate or the total amount of product being formed versus time. So this graph shows the difference between the reaction when there's a high concentration of enzyme, which is represented by the blue line, versus a low concentration of enzyme represented by the red line. As the substrate levels fall, so the amount of product made per unit time decreases. So not all the active sites are fully occupied. The rate of reaction can be increased initially, so that's when you got that steep part, by adding more enzyme. The final amount of product remains the same because we began with the same amount of substrate. So what did I mean? Well, you've got 2 graphs. You've got your high enzyme concentration, the blue, the low enzyme concentration, the red. And as time increases, so the product you've got lots of product increasing, and then it's gradually the amount of product is going to slowly lessen and lessen because your substrate's being used up. Notice how they eventually both reach the same point. Now this graph represents enzyme concentration when you've got excess substrate. So as long as there's an excess of substrate, the initial rate of reaction, which we represent by VI, is proportional to the enzyme concentration. So this is when you've got excess substrate. If you've got low enzyme concentration, so if the substrate's in excess, at low enzyme concentration, you've got, for example, 2 enzymes here. There are too few enzyme molecules to allow all the substrate molecules to bind to the active site. So the rate of reaction is therefore only half, represented by the arrow, the maximum possible for the number of substrate molecules available. If you've got intermediate enzyme concentration, this means that you've got twice as many enzyme molecules available. All the substrate molecules can occupy an active site at the same time. The rate of reaction is doubled to its maximum because all the active sites are filled. So we say that Vmax has been reached, and Vmax is all the active sites are fully occupied at the same time, and you've got enzyme substrate complexes being formed. Now if you've got excess enzyme concentration and limited substrate concentration, what is going to happen? Well, if you add further enzyme molecules, it's going to have no effect because you've already got enough active sites for those substrates to bind to. So there's going to be no increase in the rate of reaction. This is because the available substrate is already being used as rapidly as it can be by the existing enzyme molecules. So what have we learned so far? You've got an enzyme and a substrate. If you change the pH, the ionic bonds and hydrogen bonds are going to be broken in the active site, and you'll get graphs that look like this. So increase in pH at the bottom. If you change the temperature, you're going to have more collisions occurring. So remember the value Q10, so the rate should double every 10 degrees Celsius until it reaches a temperature where the enzyme starts to become denatured, so there's a drop in the curve. Substrate concentration. There's more chance of forming enzyme substrate complexes when you increase the substrate concentration. And the last one, enzyme concentration. If you've got excess substrate concentration, your graph is going to continually go up. What happens if you've only got limited substrate? Then the graph will plateau. And that concludes our lesson, the end.